Good day, everyone. I am going to discuss the chapter 2 of the book entitled Developing the Research Study. But before I begin the discussion, let me first introduce myself. I am Christian Enarca, studying Bachelor of Library and Information Science. Research planning. The first question that a researcher may well ask is, where do I begin? In other words, where does the planning begin? The planning begins in finding a problem, and intellectually curious, an inquisitive mind is the beginning of research. Gleiser states that before we begin our research process, we should consider our epistemological and ontological assumptions and presuppositions. Research planning uses two methods, which is deductive or systematic logic and inductive reasoning. Inductive reasoning is a specific observations and then draws a general conclusion, or it is from facts to theories. However, deductive or systematic logic is a specific conclusion follows a general theory. It is characterized by use of syllogism, and it is the truth of conclusion obviously depends upon the truth of basic premise. The scientific method of inquiry is the most valid method for resolving unanswered questions and solving problems. Here is the process of scientific method. First, make an observation, then ask a question. After that, form a hypothesis that answers the question, then make a prediction based on the hypothesis and do an experiment to test the prediction. And after all of that, analyze the results and you can get the answer if it is correct or incorrect. Then if the result is incorrect, you have to form a hypothesis again. Then report the result. A general outline for research is: first, make a question, then identify the problem, place the problem in its broader theoretical framework, next, hypothesis, and decide collection methodology and data techniques, and then data collection and analysis stages, and then analysis and interpretation, and you can get if your research is correct and incorrect. If your research is incorrect, you have to start the research process again. General criteria to basic research. In addition to adhering to a general outline, basic research studies generally should meet certain criteria to qualify as basic or pure research. First, universality. The study should be researchable. Second, replication. The research study is repeatable. Then, control. The parameters of the research study. Then, measurement. It constitutes the observation and recording of phenomena. A checklist for planning a research study. Scope and definition of study, hypothesis or questions to be answered, definitions, method of study, design, sampling, criteria factors, interpretation of results, and preparing the report. Identification of problem. The research problem is essentially the topic to be investigated or what needs to be known. The primary importance of identifying a problem before conducting a research is where and how the problem is found, and the answer is the problem is all around us. And for being curious, critical observer, and disagreeing with some previous research. If a would-be researcher identifies a problem, he or she should be fully familiar with the known facts and accepted ideas in the field, be knowledgeable of previous related research in the area, and be aware of gaps in knowledge in the field or unresearched areas. Estimation sheet to determine the feasibility of the research project. First, the problem. With what areas will be the problem deal? Are the data that relate directly to the problem available for each of the categories you have just checked? What academic discipline is primarily concerned with the problem? Then, the data. How available are the data to you? How often are you personally in contact with the source of data? Then, criterion-based evaluation. Does your research project meet the 4 criteria applicable to all research? Desirable characteristic of hypothesis. Generalizability or universality. A hypothesis with this trait should hold up in more than one situation. On the other hand, valid hypotheses can be formulated legitimately for specific situation. 2. Compatibility with existing knowledge. The hypothesis should not be isolated from the larger body of the knowledge. Third, testability. Regardless of its other traits, if it cannot be tested adequately, it is of little or no value. It even can be argued that the hypothesis should imply how it can be tested. Fourth, invariability. Simply put, the relationship stated in the hypothesis should not vary over a reasonable period of time. Fifth, causality. The ideal hypothesis states a relationship that is causal in nature. Many researchers also argue that the hypothesis should be predictive. Testing the hypothesis. There are two stages to accomplish the hypothesis. First, the researcher deductively develops certain logical implications which, when stated in operational terms, can help to reject or support the hypothesis. Second, involves actually subjecting it to a trial by collecting and analyzing relevant data. Validity and reliability. Validity and reliability are actually requirements for both the design and the measurement of research. Validity means true and reliability means repeatable. Generally speaking, research is considered to be valid when the conclusions are true and reliable when the findings are repeatable. But validity and reliability are actually requires for both the design and measurement of research. Regarding the design, the researcher should ask whether the conclusions are true or valid and repeatable or reliable. Measurement, of course, is the process of ascertaining the dimensions, quantity, or capacity of something, and it closely related to the notion. Validity of research design. There are three types of validity. Internal validity means particularly crucial to experimental research design. Second, the construct validity means that the design should permit the specification of the actual cause and effect and the identification of the concept or construct involved. Third, external validity. Conclusions are true or hold up beyond the confines of a particular study. Validity in measurement, the extent to which a scale measures a specific idea or concept. Logical validity. Logical validity is a type of validity generally based on expert judgment. It includes content validity and phase validity. Content validity represents the degree to which an instrument measures a specific content area. Phase validity is a sort of catch-all term often used rather loosely. It has been defined as the degree to which a test appears to measure what it claims to measure. Phase validity is usually based on the opinion of subject experts who have been asked to evaluate an instrument. Empirical validity, or the second basic type of validity regarding measurement, has been referred to as empirical and criterion-related validity. Empirical validity is based on external, objective criteria. It includes concurrent validity and predictive validity. Concurrent validity indicates the degree to which the scores on a test or other data collection instrument are related to the scores on another already validated test administered at the same time or to some other valid criterion. Concurrent validity also represents the ability of an instrument to discriminate among people or whatever who are known to differ. Predictive validity has to do with the degree to which an instrument can identify differences that will evidence themselves in the future. Reliability of research design. If the design of a research study is reliable, then its findings should be repeatable or replicable and generalizable beyond one study. Reliability and measurement. As was stated earlier, research requires that one be able to measure, concept, and construct as represented by variables which often are translated into or operationally defined as a set of categories or a scale. Unfortunately, however, virtually all measurement is imperfect. Consequently, a measurement or observed is calculated with the following formula, where SIM is standard error of measurement, SD is the standard deviation of scores, and R reliability coefficient. Scales. There are generally considered to be four types of measurement scales. First, numerical scale. The numerical or categorical scale consists of two or more named categories into which objects, individuals, or responses are classified. Second, ordinal scales. An ordinal scale defines the relative opposition of objects or individuals with respect to a characteristic with no implication as to distance between positions. Third, internal scale. The interval scale provides a ranking of positions as does the ordinal scale, but the intervals of measurement are equal. In addition, the interval scale has a 0 point below which scores are given a negative value if they occur. A temperature scale is an example of an interval scale. Interval level data are less common than ordinal in the social sciences. Fourth, ratio scale. Ratio scale allows one to compare the magnitude of responses of or measurements. That's all. Thank you.